In this video, we are going to be covering section 3.4, dividing polynomials. So the first thing that we have to talk about is the division algorithm, which says that given a polynomial dividend f of x, that's the polynomial that we're trying to divide, and a non-zero polynomial divisor d of x, that's what we're trying to divide f of x by, where the degree of d of x is less than or equal to the degree of f of x, which we just require so that we aren't trying to divide a polynomial of lower degree by a polynomial of higher degree. There exists unique polynomials q of x and r of x such that f of x is equal to d of x times q of x plus r of x, where q of x is going to be the quotient and r of x is going to be the remainder that result from the division process. And the remainder is either equal to 0 or has degree strictly less than d of x. If r of x is equal to 0, then d of x divides evenly into f of x. This means that in this case, both d of x and q of x are factors of f of x. So if r of x is equal to 0, then f of x is just going to be equal to d of x times q of x, which shows that d of x and q of x are both factors of f of x. So that might sound a little bit confusing. So let's just talk about these steps for dividing a polynomial by a binomial, which is just going to be any expression of the form a of x to the n plus b of x to the m, where n is greater than m. So the first thing we are going to do is set up the division problem like we normally would when it comes to long division of numbers. Then we want to determine the first term of the quotient by dividing the leading term of the dividend by the leading term of the divisor. And then we want to multiply our answer, so whichever term we get for the quotient, by the entire divisor. So all the terms in the divisor are going to get multiplied by the quotient, and write it below the terms of the dividend. And then we are going to subtract the bottom binomial from the top binomial. And then we are going to bring down the next term of the dividend. And then we're just going to repeat steps 2 through 5 until reaching the last term of the dividend. And if the remainder is non-zero, we are going to express it as a fraction using the divisor as the denominator of that fraction. All right, so let's get into the examples. So we are going to divide 16x cubed minus 12x squared plus 20x minus 3. So that's our dividend polynomial by 4x plus 5. So that's the binomial that we're trying to divide this polynomial by. So let's start by just setting up the long division like we normally would. So we will put 4x5 over here where the divisor goes. And then we will write our dividend, 16x cubed minus 12x squared plus 20x minus 3 right there. And then we're going to form our quotient above. So the first thing we want to check is how many times does 4x go into 16x cubed, right? Because that was step 2. So we want to determine the first term of the quotient by dividing the leading term of the dividend by the leading term of the divisor. So the leading term of the dividend here is 16x cubed, and the leading term of the divisor is 4x. So let's go off to the side and look at dividing 16x cubed by 4x. Well, the first thing we can do is we can cancel out. So 16 is equal to 4 times 4, or 4 squared. So we can cancel out a factor of 4 from 16 with the 4 in the denominator. And then For x cubed over x, well, each of these guys has a factor of x that we can peel off and cancel out. So we can cancel this x in the denominator with one of the factors of x in the numerator, which will decrease the exponent in the numerator to 2. So after we reduce, we end up with 4x squared. So that's going to be our first term for the quotient here is 4x squared. And then we want to multiply 4x plus 5 by 4x squared and subtract the resulting binomial from the first two terms of our dividend. So 4x squared times 4x plus 5 is going to be, well, 16x cubed for 4x times 4x squared. Kind of already know that. And then 5 times 4x squared is just going to be 20x squared, so plus 20x squared. And then we're going to subtract both these terms from the dividend. So minus minus. And then we're going to have, so minus 12x squared. Well, so first of all, 16x cubed minus 16x cubed, those guys are going to cancel each other out. And then moving on to the next two terms, we have minus 12x squared minus 20x squared, which is going to be a minus 32x squared. Okay, and then we want to bring down the 20x. So plus 20x. Okay, and then now we want to see, okay, how many times does 4x go into minus 32x? So let's go off to the side here. We'll write minus 32x squared, that is. We'll write minus 32x squared over 4x. So with minus 32, so 32 is equal to 8 times 4. So we can peel off a factor of 4 from 32 and cancel that with the 4 in the denominator. So we'll have an 8 still up here, and then that 4 is going to get canceled out. And then we can cancel the x in the denominator with one of the two factors of x in the numerator, since we have x squared up there. So we end up with minus 8x. So that's going to be our next term for the quotient, so minus 8x. And then we want to multiply our binomial 4x plus 5 by minus 8x. So minus 8x times 4x is going to be minus 32x squared. And then minus 8x times 5 is going to be a minus 40x. Okay, and then we're subtracting these guys. So we have minus 32x minus minus, so plus 32x. Those guys are going to cancel each other out. And then we have 20x minus a minus 40x. So we're going to have minus minus is a plus. So we have 20x plus 40x, which is 60x. And then we want to bring down the minus 3. So minus 3, and then now we want to see, okay, how many times does 4x go into 60x? Which really just comes down to dividing 60 by 4. So the x's are going to cancel out, of course. And then 60 is equal to 4 times 15. So what we're going to end up with is 15. And that's going to be our next term for the quotient. So plus 15. Okay, and then we want to multiply 4x plus 5 by 15 to see if we have any sort of remainder. So 15 times 4x is going to be 60x, of course. And then 15 times 5 is going to be 75. and we're going to subtract, and so we end up with minus 3 minus 75 is going to be minus 78, which is going to be our remainder. All right, and so what we end up with, well, let's go off to the side here. So we have 16x cubed minus 12x squared plus 20x minus 3. We divided this by 4x plus 5. And we found that this is equal to 4x squared minus 8x plus 15 with a remainder of minus 78. So we are going to, again, according to the steps, write our remainder as minus 78 over 4x plus 5. Okay. So in our next example, it says that the volume of a rectangular solid is given by 3x to the 4 minus 3x cubed minus 3x squared plus 54x. So that's like our volume v of x. And the length of the solid is given by 3 times x. And the width is given by x minus 2. And it wants us to find an expression for the height of the rectangle in terms of x. So what we are going to do is we are going to divide this polynomial for the volume by first the polynomial for the length, so 3x, and then the polynomial, or to be more specific, the binomial for the width, so x minus 2. And then what we get for the quotient will be our expression for the height of the rectangle. So that's our polynomial v of x. This is L of x. This is w of x. And then we want to find an expression for the height, which we can call h of x. And so what's going on here is that, well, v of x, so the volume of a rectangular solid, is going to equal the length times the width times the height. So v of x is just going to be equal to L of x times w of x times h of x. And so this is why if we just divide v of x by L of x and then w of x, what remains will just be h of x. All right. So first, let's divide v of x by 3x. So here we could, since we have just a single term for the divisor, we could just go through term by term to divide v of x here by L of x. So we could think about, avoiding setting up the long division and just writing v of x over L of x and just seeing how things would cancel out. Or we can do the long division. So let's see. Yeah, I suppose we'll just use the long division. That way we don't confuse things a whole lot by doing something different. So 3x for our divisor, and then 3x to the 4 minus 3x cubed minus 33x squared plus 54x. All right, so first we want to check how many times does 3 of x go into 3 times x to the 4. And well, the 3's are of course going to cancel out when we look at 3 times x to the 4 over 3 times x. So the 3's will cancel out and we'll just have x to the 4 over x. And what we can do is cancel out one of the 4 factors of x in the numerator with the factor of x in the denominator, and what we're left with is x cubed. So that's going to be our first quotient, or our first term for the quotient is x cubed. And then we will take 3x and multiply that by x cubed. So that's just going to be 3x to the 4. Subtract that. Of course, these guys are going to cancel each other out. So we have 0 and then minus 3x cubed. And I'm just going to neglect writing the 0. All right, so minus 3x cubed. So now we want to check how many times does 3x go into that. Well, once again, the 3's are going to cancel out. And after we cancel out the factors of x with each other, what we'll be left with is minus x squared. So minus x squared is our next term. Okay, and then we'll multiply 3x by minus x squared. So that's going to be minus 3x cubed. These guys are going to cancel each other out. And so we will bring down the next term, which is going to be a minus 33x squared. And 3x goes into minus 33x squared. Well, 33 is equal to 3 times 11. So we could cancel out the 3's with each other, and we would have a minus 11 remaining for the coefficient. And then after we cancel out the factors of x with each other, we'll be left with just one factor of x in the numerator. So we'll have minus 11x for our next term for the quotient. And then multiplying 3x by minus 11x is going to give us minus 33x squared. Okay. And I'm going to move things around really quick because we're running out of vertical space. Okay, so the 33x squareds are going to cancel each other out, or rather the minus 33x squareds are going to cancel each other out when we take their difference, of course. So we'll bring down the next term. So we have 54x. And then once again, this kind of just comes down to dividing 54 by 3 because the x's will cancel each other out. And so we have 54 is equal to 3 times 18. So 54x over 3x is going to be 18 plus 18. So that's going to be our next term for the quotient, is plus 18. And we'll bring that down, or sorry, we'll multiply 3x by 18. So that gives us 54x. Once again, we'll subtract that from 54x, and well, that's going to give us 0, which is our remainder. Okay. All right, so after we divide v of x by L of x, what we have is x cubed minus x squared minus 11x plus 18. So this is what w of x times h of x is equal to, is this current quotient right here. So now all we have to do is divide this by w of x, and all we'll have left is our expression for h of x. So let's go. Now our divisor is going to be x minus 2. It's our expression for w of x. And then we are trying to use x cubed minus x squared minus 11x plus 18 for our dividend. Okay. All right, so first we want to check, okay, how many times does x go into x cubed? Well, that's just going to be x squared times. So we'll write x squared as our first term for the quotient, and then we're going to multiply x minus 2 by x squared. So we're going to have x cubed for x squared times x, and then minus 2 times x squared is going to be minus 2x squared. So we subtract both these terms from the first two terms of our current dividend. And what we get is, well, the x cubes are going to cancel each other out. And then we have minus x squared minus a minus 2x squared, which is going to give us, well, minus x squared plus 2x squared. So a positive x squared. And then we'll bring down the minus 11x. So minus 11x. And then we want to see, okay, how many times does x go into x squared? Well, it's going to go into that just x times. So that's going to be our next term for the quotient x. And we're going to multiply x minus 2 by x. And that's going to give us x squared minus 2x. And we're subtracting this now. And so we're going to have x squared minus x squared. Those guys cancel each other out. Then we have minus 11x minus minus 2x. So minus 11x plus 2x, which is going to be minus 9x. And then we want to bring down the last term for our dividend, plus 18. Okay, and then we want to see, okay, how many times does x go into minus 9x? Well, it goes into it minus 9 times. And then we want to multiply x minus 2 by minus 9. Well, that's going to give us minus 9x, and then minus 2 times minus 9 is going to give us plus 18. And we're going to subtract these guys, and so our remainder is going to be 0. And this polynomial that we have in on top here, our quotient, in this second division. Let me see. Trying to make this a little bit bigger. So x squared plus x minus 9 is going to be our expression for h of x. So x squared plus x minus 9 is h of x. Okay, so that's how we do polynomial long division. We are next going to talk about synthetic division. So it is a shortcut which we can use, like it's a shortcut to polynomial long division that we can use when the divisor is a binomial in the form x minus k or x plus k. It just depends on if k is positive or negative. And in synthetic division, only the coefficients are used in the division process. So no longer are we like worried about, what degree terms we're looking at. We're just worried about the numbers in front of those terms. And so the steps for using synthetic division, which again is only to divide a polynomial by a binomial of the form x minus k. What we want to do is write k for the divisor. So if we have x minus k for our binomial, then we're going to use a positive k for the divisor. If we had x plus k, then we'd use a minus k for the divisor. And then we will write the coefficients of the dividend. And then we will bring the leading coefficient down. And we will then multiply the leading coefficient by k. Like after we bring that leading coefficient down. And then we'll write the product in the next column. And then we will add the terms of the second column. So we will add the second term for our dividend with the term that we get from multiplying k by the leading coefficient, or the first term of our dividend. And then we want to multiply the result, like after we add those two things together, by k. And we will write the product in the next column, and then we will just start repeating steps 5 and 6 for the remaining columns. And we will use the bottom numbers to write the quotient. So the number in the last column, the rightmost column, is going to be our remainder. And so if it's not 0, we would just write our remainder over x minus k. And then the next number from the right is going to have degree 0. So it's going to be our constant term for our quotient. And the next number from the right has degree 1, and so on. So essentially what we get at the bottom after we finish our synthetic division process are going to be the coefficients for the quotient polynomial, along with the remainder. So I realize that definitely does sound confusing just reading it. So let's look at some examples where we use synthetic division. So the first thing we're going to do is try to use synthetic division to divide 3x to the 4 plus 18x cubed minus 3x plus 40 by x plus 7. So since we have x plus 7, that means our divisor is going to be a negative 7. And then in this top row next to our divisor, we are going to put the coefficients for our dividend. So 3, 18, minus 3, and 40. Oh, wait. And actually, so we want to be careful here. So you do want to be careful when you're using synthetic division. You need to have a place for every term of the polynomial that has lower degree than the highest degree term. So this way, so for instance here, there's no x squared term, so that means its coefficient is 0. So we want to put a 0 here after 18, because that's the coefficient for the x squared term, and then minus 3 for the degree 1 term, and then 40 for our constant term. So yeah, if you're ever looking to use synthetic division to divide a polynomial by a binomial, check and see what the highest degree term for your dividend polynomial is. And then check to see if there are any terms of lower degree missing from the expression for your polynomial. Because if they are, then that just means that term had a coefficient of 0. And so you want to include that 0 as like a placeholder in your synthetic division process. All right. So just like the directions said, the first thing we're going to do is just bring down that leading coefficient 3. And the reason for this is if we were actually dividing this using long division, well, x is going to go into 3x to the 4 3 times x cubed times. But we're not really worried about the variable here. We're just worried about the coefficients. So x goes into 3x to the 4 3x cubed times where, our focus is that coefficient 3. And then we'll worry about, what degree terms these coefficients go with at the end. Okay, and then we want to multiply 3 by -7, so that's going to be -21 for the product, and we're going to add that to 18. So 18 plus -21 is going to be -3. And then we want to multiply by -3 by -7 now, which is going to be a +21, and we're going to add that to 0. That's going to give us just 21. Multiply that by 7, or by -7, and that's going to give us -147. And we want to add that to -3, which is going to give us -150. And then we want to multiply -150 by -7, which is going to give us 1050 for the product. And we want to add that to 40, so that's going to give us 1090. Okay. And so this is our remainder. This is our constant term for the quotient, so -150. This is going to be our degree 1 term, so 21x. This is going to be our degree 2 term, so -3x squared. And this is going to be our degree 3 term, so 3x cubed. So 3x to the 4 plus 18x cubed minus 3x plus 40 divided by x plus 7 is going to be equal to 3x cubed minus 3x squared plus 21x minus 150 and then plus 1090 over x plus 7. And yeah, when you're initially thinking about how to write the terms, do it in like the reverse order from how I just wrote them. So before we started writing the terms down here for our answer, if y'all recall just a moment ago, I first started with saying, okay, 1090 is going to be our remainder, minus 150 is going to be the constant term, and so on. So you kind of want to build up with the terms when you're trying to match them to the coefficients. And so that's it for this section of the notes. And I realize we only looked at one example using synthetic division, but don't worry, in the next section of notes, we will have 2 more examples where we're doing synthetic division. So just hold up for the next section of notes, and in that video, we will look at a few more examples where we use synthetic division.